Good morning, students. We are studying NCERT Class 8th Math Part 1, Chapter number 4, Quadrilaterals. Today is 18 August 2026. In yesterday's class, we were doing the problems which are mentioned at the end of this chapter, and we will continue with the problem number 6. What is the problem number 6? That we will see. Problem number 6 is construct a square with diagonal 6 cm without using protractor. Protractor means you need to measure. You should not be using protractor, and we have to draw a square with having diagonal 6 cm. Okay, I'll tell you the procedure. Now see, to construct a square with diagonal 6 cm, first draw the diagonal. See, this is diagonal and the length is 6 cm. Understood? How will you find out the midpoint of this? As we have already discussed that by using the compass and having radius more than the half of this length approximately, when you make arc on both sides by using the end point of this line segment, you will make a arc like this, and from this side this arc you have made from this end, and this arc you will make from this end and this end, and these 2 points we have to join, and this is midpoint. Understood? Now this is midpoint of the one diagonal which is of 6 cm. Now from this point you measure with the help of your protractor. Just measure this with the help of your compass. Measure, take it as a radius and place here and make a mark. When you mark here of 3 cm and mark here also at the bottom of this 3 cm. Understood? Then this is also the midpoint of this line segment, and we will see that now this will act as another diagonal of the square, and this diagonal you have already made. The length of this diagonal is 6 cm. Since we have taken this as a radius and we have marked this, so the length of this diagonal is also 6 cm, and we see in this way when we find the midpoint of the line segment. So the line which we draw is perpendicular to the baseline. So they are perpendicular to each other, and now this is all our construction. Now what we have to do? We have to join the endpoints of the diagonals and erase the additional part. Now we will join. Now A, C, B, D. So these are our diagonals and all sides are equal. To find out the, now this length you can also find out. Understood? By using the Pythagoras theorem, if you know, this is 3, this is 3, so this will be 3 under root 2. By using the Pythagoras theorem, you can find out. Actually, this is not asked in a question. Only what asked in our question, that to draw the square having one diagonal 6 cm. We know in the diagonal in a square, both diagonals are equal, they intersect or bisect each other at an angle of 90 degree. So this is the required diagram. Understood? And we have not used any protector. This figure will be can be made by using compass. Okay, so this is our question number 6. Now we will move to the question number 7. Now see, what is our question number 7? They are saying that a square is given, and it's with the endpoints of the sides of the square. We have made another figure by joining those end midpoints, and we have to observe what is the result resultant quadrilateral. Understood? And after coming to the result, we have to find that whether such same type of quadrilaterals we are able to draw or not. Understood? That we'll see. This square has been given CASE. Understood? Right. And what are the midpoints? UXWV. UXWV. Now these are the midpoints of the sides of the square CASE. What the instruction is given, we have to join these midpoints. Now they are asking, what is this figure? Understood? So what is this figure? If you say, if we take these two triangles, triangle this one and triangle UCV and triangle UAX. Understood? In triangles CUV and triangle UAX. Now see, this side is equal to this side, and this is equal to this side, because and this side. All sides are, two sides are equal, and this angle is 90 degree. This angle is 90 degree. Understood? We can write here CU is equal to UA and CV is equal to AX, and angle C is equal to angle A, that is 90 degree. So these triangles are congruent triangle. CUV is congruent triangle UAX. Understood? That means that by corresponding part of congruent triangle UV is equal to UX. And in the same way, when we take these two triangles, we see that UV is equal to VW. And also when we take this triangle, we say UA UX is equal to XW. And with this result, we find out that UV is equal to VX is equal to XW is equal to WV. Understood? all sides are equal. Now what about this angle? See, by corresponding part of congruent triangle in these two, we'll see, or we can say that in this triangle these two sides are equal and this angle is 90 degree. So this angle is also equal to this angle and both sum is 90 degree. Understood? Both sum is 90 degree. So each angle is 45 degree. In the same way, when you will find out that all the angles are 45 degree, and in a straight line, when you try to find out the internal angle, what you will see that 90 plus 90, this is 180 minus 45 plus 45, so that this become 90 degree, and in the same way all the internal angles are 90 degree. Understood? This is 90 degree. Understood? This is 90 degree, and though these two angles are equal, so they are 45. In the same manner, this is also 45, this angle 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 is also 45, and this angle is also 45. When you see, uh, when you try to find out this internal angle, that's 45 means 180 minus 45 plus 45, this comes out as 90 degree. In the same way, this is also 90 degree, and same way you will find out this is also 90 degree and this is also 90 degree. So what is the result? That all the internal angles are 90 degree and all the sides are equal. It means this figure is square. This figure is square. Understood? The figure which is joined by joining the midpoints of the sides of the square is also a square. This is our result. Now what they have said further in this question: is there any other way to draw a square inside a square other than joining the midpoint? The further part of the question is that, is there any other way to draw a square other than joining the midpoints of the sides of the square inside a square? So this is a square, we can say. If they have given the another name, let's see. No, they have not given any name, so we'll take the same name, CASE. Understood? Now see, we can draw any number of a square. Understood? The thing is that from each point you have to take equal distance every time in every side. If you have taken, yeah, from here to here 1 centimeter this point, then again take from here 1 centimeter, and from here 1 centimeter, and from here 1 centimeter. When you simply join these points, it is definitely a square, and geometrically you can prove it. Understood? So there are n number of ways. Now you can take anywhere the distance. From here, if you taken the distance here, the same way this side, the same way this side. Since I am drawing on a whiteboard, this might not be the exact. Now when you join these points also, you will find this is a another square. In this way you can draw any number of a square inside a square. What point you should keep in your mind? You should keep in your mind that from the vertices, uh, what the distance you have taken on the side of the one side of the square, the same distance you have to take from the other side of the square. And when you join these 4 points, you will get the another square inside a square. Now we will move to the next question, which is question number 8. Let's see what is. If a quadrilateral has four equal sides and one angle is 90 degree, means you have given a four equal sides and one angle is 90 degree. What will be? Will it be a square? Find your answer by using the geometric reasons as well as by construction and measurement. Understood? Now what they are saying, see, a quadrilateral is having four equal sides and one angle is 90 degree. What does it mean? Now this is, you have drawn a quadrilateral in which all sides are equal, means four equal sides. All sides are equal. This is a symbol for equal side. Now see what they are saying, that one angle is your 90 degree. Now one angle is your 90 degree and all sides are equal. What you will observe, suppose you join this diagonal and take these two triangles, you will find out that this triangle is congruent triangle to this triangle, means triangle ADC is congruent triangle ABC. How? This side is equal to this side is equal to this side, and this is common side by SSS. Understood? And by CPCT you will find out that this this angle is 90 degree, means angle D is also 90 degree, means opposite angle are equal. Now since you know that this angle is 90 degree, because this one angle is given, when you join the another diagonal and you compare these two triangle ABD is congruent triangle AC, sorry, BCD. BCD. Understood? What does that mean? That angle A is equal to angle C. By corresponding part of congruent triangle, angle A is equal to angle C. And what more? Since this is 90 degree, this is 90 degree, total is 180 degree, and the rest of the angle is also 360 minus 180 degree, and these both are equal. It means that that angle is also 90 degree, means angle A is equal to angle C is equal to 90 degree. Understood? In a quadrilateral we know the sum is 360. So we know these two angles, the sum of these two angles is 180. So the left is that sum of these angle is left, which is 360 minus the sum of these angle, that is 180. So that is left 180. Now these two angles are also equal, which we have proved, means 180 when we divide it into two equal parts, that is 90. So it is also become 90 degree. This is also 90 degree and this is also 90 degree. When all the internal angles are 90 degree and your sides are equal, what does mean? It is a square. Definitely it is a square. Now how you will do this? By construction method. Draw a line, take it as a radius. Understood? Take it as a radius and make a arc here and make a arc here. Now first of all, how we have to draw the 90 degree? If you know, Do you know how to draw the 90° by using only compass? See, I'll tell you, just see here. This is the line segment and you have a compass here. Use this endpoint and make a arc more than semicircle. Understood? Make a arc more than semicircle. Now again use this as a your endpoint, and with the same radius, make a arc. First arc. This first arc is your 60°. Make another arc. Now again take this as a endpoint. Make another arc with the same radius. Now this is your 120°. Now you have to find out the midpoint of this. How will you find out? Take a longer radius and from this point make a arc here, and again from this point make a arc here, and which you will join. This is 90°. In this way you can draw the 90° by using only compass. And then you know the length of this line segment. You extend or reduce it as per your the length which you have taken, and in this case we will increase. So this is the length. Understood? Now you have drawn a figure. One is 90°, one angle is 90°, and two sides are equal. Now we have to draw the other two sides are also. Understood? So take it as a radius. Take it as a radius and mark here and make a arc, and take this as a radius and using this as a end point make a mark. Now you find the another point. When you will join it, it means that all the sides are equal. Understood? Now all the sides are equal and one angle is your 90°. Understood? Now we got this figure. Now you will measure all the other angles. What you will came to know that? You will came to know that all angles are 90°. So this is by construction. You can also find out that the figure will come as a, the figure will be a square. Now we will move to the next question. The next question: what type of quadrilateral is one in which the opposite sides are equal? Draw a diagonal and check your congruent triangles. Since now see, if opposite sides are equal, what could be the opposite sides are equal? So what it could be? It could be a rectangle, it could be a rhombus, and it could be a parallelogram, and it could be a square. Understood? So this is the property that we have already seen, that when opposite sides are equal, it means they are mentioning that both opposite sides are equal. So these are the four options, and it could be a rectangle, square, rhombus, or parallelogram. Hint: draw a diagonal and check the congruent triangles. So we can draw the diagonal and check for the congruent triangles also. Now since we have drawn opposite sides are equal, understood? Opposite sides are equal. Join the diagonal, and we can prove these two triangles congruent. Means in triangle this side is equal to this side, in triangle this side is equal to this side, and this side is common. So by S criteria, both triangles are congruent. The same thing you can do with the another diagonal. This is also we have done in the previous problem also. So these two triangles are also congruent. Now we will see the next question. What is the next question? Now they are saying that they have given you one quadrilateral, which is not the normal quadrilateral which we have studied till now. It is this quadrilateral is uh, here is one angle is obtuse angle, understood? And just we have to verify that the sum of the internal angles are 360 or not. See, what is your question number 10? Question number 10 is, we have given a quadrilateral like this. Figure may vary, and what they are asking, what is the sum of the internal angle of this quadrilateral? Now we see here is this one angle is obtuse and all other angle are acute. What we will say, how will you prove that all the internal angles are 180 degree? If we name it as A, B, C, D, simply join AC. Now in both triangle, you know the sum of the internal angles are 180 degree. If we name it 1, 2, 3, 4, and this is 5, and this is 6. What we will see? Angle 1 plus angle 5 plus angle 2 is 180 degree. Understood? Also angle 3 plus angle 6 plus angle 4 is 180 degree. And what we say? Angle 5 plus angle 6 is equal to angle C. And when we combine it, and we simply write angle 5 plus angle 6 as a C and rest of the angle as A, B, C, D, we will see that angle A plus angle B plus angle C plus angle D is equal to 180 plus 180, that is 360. Understood? So all the quadrilaterals, any type of quadrilateral, whether regular or irregular quadrilateral, or regular means a definite shape, irregular means of any shape, the internal angles are always, sum of the internal angles are always 360. Now we will move to the next question. Next question is true or false. We'll see one by one. A quadrilateral whose diagonals are equal and bisect each other must be a square. If you know the properties of rhombus, rectangle, square, parallelogram, you can very easily answer that this is false, because in case of rectangle, the diagonals are equal and bisect each other, but they that is not a square. So one is false. Why? It is not definitely a square. It may be a square. The answer is may be a square. And we have seen that in case of rectangle, in case of square, and in case of rhombus, diagonals intersect each other and bisect each other. Understood? And they are of equal length also. Understood? And they are of equal length also. Sorry, in case of rhombus, yes, in case of rhombus they are not equal length. So that figure is not must be a square, may be a square, because it may be a rectangle. It means what does it mean? It means that one is false, and I have given you the explanation. What is second? A quadrilateral having three angles or right angle must be a rectangle. Yes, but not necessarily, because it can be a square also. Understood? Means when three angles are 90 degree, though then the other angle is what? 360 minus 90 plus 90 plus 90, and your result will come as a 90. So the other angle is also 90. When three angles are 90, so this is also 90. So other last angle, the fourth angle is also 90 degree, and you are saying that this is the quadrilateral. Then since they are saying the must, it may be a rectangle or it may be a square. So second is also false. Second is also false. Now we'll see the third one. What is third one? A quadrilateral whose diagonals bisect each other must be a parallelogram. No. We know that a square is also a parallelogram. We know that a square rhombus is also a parallelogram, and we know that rectangle is also a parallelogram. So the answer is yes, means it is definitely a parallelogram. Understood? If the diagonals bisect each other, it means it is a parallelogram. And what in case of fourth? A quadrilateral whose diagonals are perpendicular to each other must be a rhombus. No, fourth is wrong, because in case of square also diagonals are perpendicular to each other. The fourth one is false, because in case of rhombus and in case of where we have seen kite, what we have seen, diagonals are perpendicular to each other, and in case of square also diagonals are perpendicular to each other. So must be a rhombus is wrong. It may be. Understood? It may be a rhombus, but must be is wrong. So 4 is wrong. Fifth one, a quadrilateral in which opposite angles are equal must be a parallelogram. We have seen that in a parallelogram, opposite angles are equal. Understood? So it is definitely a parallelogram. So your 5 is correct. A quadrilateral in which all angles are equal is a rectangle. Of course, when all the angles are equal, it is a rectangle, and a square is also a rectangle. So sixth one is your, fifth one is true. Fifth is true, and sixth is also true. Isosceles trapeziums are parallelograms? No. If you remember the diagram of isosceles trapezium, we see in a parallelogram opposite sides are parallel, but in case of parallelogram, one pair of opposite sides are parallel and the other two sides are of equal length. Understood? Means these two sides are parallel and these two sides are having equal length, but they are not parallel, which is the definition of parallelogram. So isosceles triangle is not a parallelogram. So your seventh one statement is false. Understood? Seventh one statement is false. So in this way, this is the end of this chapter. We have finished the chapter number 4, quadrilateral. Understood? And we have done all the exercises. Now in summary, you can go through the summary so that you will have a quick revision of the complete chapter. Understood? And at the end of this chapter, there is a puzzle given that you have to fold a paper sheet into uh, uh, two half. I mean, you have to fold it twice, and you will get the 1/4 part of the paper, and you have to fold one corner. Then you will see different types of figure is visible. Let's see. Let's do this experiment and let's finish this chapter. Now see, we have this A3 size paper. We have folded it once. Understood? We have folded it once, and we have folded twice. Now, the which is the center part of the paper, we have to fold some more side. Now we have seen, if you see, this paper is divided into 4 equal parts, and now we have to fold here. Now see, I have fold it like this at this corner. When I open this paper, you will see a diagram. Then you see what is the diagram. Now you can see, if it is visible to you, it is a rhombus in which all sides are equal and diagonals are perpendicular. And in this way you can draw and you can make series of rhombus if you make more folds. And now in this way you are getting the exact rhombus. Understood? What you are getting? You are getting the exact rhombus, and any number of rhombus you can get, since I am folding it 2 times or 3 times. Understood? Now when I will open this paper, you will observe that the figure which you see is rhombus. All the figures are rhombus. Now what they are saying, can you make a square? Can you make a square by folding this? Of course. How will you make a square? You have to fold in such a way that this side is equal to this side. Understood? Or I have folded it, and I just try to fold it. Let me see whether you are able to see the figure of a square, if it comes out to be a square. No, it is actually not visible. We'll use the next paper. Now see, we have folded once and folded twice. In the previous folding we have seen that it is a rhombus. Now we will fold it in such a way that this should be equal to this side. Now when I open this paper, it should look like a square. Yes, can you see? It is a square, and you can make many more squares like this. Let's try to do one more. Now you will see another square. Understood? You can see all the sides are equal and diagonals are perpendicular to each other. Understood? So this is the way you can get a perfect square by simply folding a paper. Now this is the end of this chapter, class. Students, dear students, and we have finished the chapter number 4, and from tomorrow onwards we will start with the next chapter, and that is your chapter number 5, numbers play. Till then, take care and thank you very much.